thank you. Well, thank you, Ed, first, for inviting us here and organizing this wonderful symposium. And thank you, everybody, for making it to our 8:30 session. I'm really impressed, and thank you, Cynthia, for giving the first talk. It's, yeah. So my talk, it's a nice follow-up from Cynthia's work. We'll focus on embodied aesthetics and sensorimotor experience. And when I prepared this talk, I was not very sure what to put on it, because in the first email we got from Ed, he said that he didn't want a review of our work. He just wanted a room for communication and engagement. So I'm not sure I've done that very well. So I put a lot of my work here, and, but also with the idea that you can pick up some of the techniques and ways of measuring embodiment that we have in our lab, so maybe we can foster some new collaborations or some new research. Okay, so I start by the beginning. I would like to explain how I got into the neuroaesthetic of dance. So the beginnings for me, it's not like how many people will expect. I'm not necessarily a very good dancer myself. None of you saw me dancing after the Central Bar evening yesterday. So the beginnings for me in the neuroscience of dance started when I was doing my PhD, and I was basically interested in investigating the neural mechanism involved in observing other people's movement. And I was particularly interested in what happened to see when you see movements that you don't know yourself, because all these ideas of the mirror neuron at that time, they suggested that seeing movements allows an internal motor simulation, but sometimes we do see movement, and I represent myself like this random observer with no any dance experience, and we see people doing movements that we cannot do, and we cannot understand them. So what's happening in our brain there? So what we did basically is compare what happened in the brain when I observe movements that I'm familiar with, for example, this case, and movements that I'm not familiar with. And that was basically the first work that I did with these lovely people that many of you know, some of them here. And we spent some time recruiting ballet dancers from the Royal Ballet in London and capoeira dancers, and we put them in the scanner, and we look at the particular contrast, what happened with ballet dancers, look at ballet, so the movement they know, as compared when they look at a movement that they don't know, and the same for the capoeira people. What happened when the capoeira people look movements that they know compared to movements that they don't know. And what we found is that there was a stronger activation in the classical areas that belong to the mirror neuron system or action observation network. And what was more interesting is that the pattern in these areas here, in the premotor cortex, so the intensity, the activity in these areas was stronger for the people who knew the movement. So these are ballet dancers looking at ballet as compared to ballet dancers looking at capoeira, and the same for the capoeira group. While if you are a non-dancer like myself, you don't represent much difference between seeing a ballet movement or a capoeira movement. So that was the beginning for me in this area. And then we thought, okay, so when we are observing other people's actions in the brain, familiarity matters. So what else matters? And the obvious question after working with dancers for a while was to see what happened when we see dance that we like. So we went back to our data, and that's basically what we did. We asked the same participants to rate in different scales how much they like or dislike the movements that they saw in the scanner. Like that, we created a set of movements, a set of movements that people like, and a set of movements that people dislike, and we look at what areas in the brain are sensitive to this pattern. And we found that there was this area here, the dorsal premotor cortex, that was more active when people saw movements that they have selected as like, as compared to those ones that they dislike. So we suggested some kind of sensorimotor aesthetics, and that these sensorimotor areas involved in action observation, they might be also sensitive to the preference of the observer. Therefore, we have familiarity and preference that matter. And then we had to take a breath and say, okay, what else? Where are we going from here? And we took a look at the dance, and we thought the dance actually is a very complex stimuli. We normally don't see the dance in isolation. We normally see it in a context. We normally have some expectations to it. It normally doesn't come by itself. It comes with a company of several more individuals, and we normally only study dance in isolation until Guido came along, so you'll see later. Also, sometimes often come with music. So there are many factors to control here. So we wanted to have all two kinds of observers, the non-expert observer and the observer, and see how they are influenced by the different factors that they are observing. Some comments that we were getting along all the time was this kind of comments coming mainly from the artistic community, and they told us that our stimuli were unfortunately not very ecological. These are the kind of stimuli we were using before. So they are 3-second clips, and we put them in the fMRI. What I really take the point, but I think that for now, or at least at that time, I was really concerned with the idea that action is a very complex stimuli, and rather than looking at many other information together, what we needed to do is decompose the action in its individual parts. So we wanted to tell apart the dancer from the dance. So from here on, the series of studies that we were doing were isolating on one side the dancer, the body in itself, and how we process body information, and on the other side, the kinematic, the dynamic information of the movement. So body studies are the ones I'm going to present in the following slides. We have static bodies, and for the kinematics, basically what we did is that we attach points of lights to the main joints of a dancer, and this we did it in a very less sophisticated way than yesterday. So at that time, I think there were not these lovely suits. So we basically put reflectant tape to the dancers, and we made video in a kind of dark room and do a lot of video editing, and we got things like this. So we got videos of this type, where you cannot appreciate the type of the body of the dancer, but you can fully appreciate the dynamic of the movement. And we did two types of studies, as I said, because we have dynamic information here. These studies were using a particular technique like fMRI, because you can have 3 seconds long videos and look at the brain activity there. And since, actually, I just put this slide on because of Cynthia's work, we did a study where we look at the visual discrimination between pairs of point light displays of different dance, and we asked participants to decide which one they prefer, or to tell a small difference between them. So an aesthetic task or a visual discrimination task, and what we found is a strong activation bilateral in the somatosensory cortex, what I think fits very nice with the data that Cynthia presented before. But I'm going to talk a bit more about the body studies. And the reason why I like the body studies is because it allows you to use other techniques like TMS, when we can have very short stimuli and quick resolution, and also ERPs. Okay? So the first study of the body studies is the one that was mentioned before, was done also in collaboration with Guido. It was our first and last paper together. I wonder what did I do? I thought we had fun, so we did this in Salvatore Agliotti lab in Italy with Cosimo Urgesi, and the question was very simple. At that time was a time where EBA was the area processing bodies, And Cosimo, Jesse, and Salvatore also suggested that premotor cortex was very involved in processing other aspects of the bodies. So we wanted to see if you apply TMS over EBA or premotor cortex, if you disrupt the visual percept that is necessary for aesthetic judgment. So people had to do an aesthetic task on body stimuli, and we applied TMS after the first stimuli, or on a scrambled set of pictures. And then what we found was actually very nice. So as I said, we have bilateral repetitive TMS over EBA and premotor cortex. And so let me explain you how is this figure. Basically, this line here, it's the subjective ratings of the individual image outside the experiment. And then variation from this line are difference evoked by the TMS. And what we found is that applying TMS over these areas doesn't change very much your preference in the scramble stimuli, but it changes your preference when you apply TMS in the body area and in the ventral premotor cortex. And that different change in different directions. So I don't think we can tell much more about this study apart from the fact that both areas, EBA and premotor, are involved, or they take a role, a causal role, or they provide some information for the aesthetic judgment of body processing. I don't think we can tell what role is it, but definitely they both play a differential role in this processing. And then, so that was also the time where, after talking about body perception all the time, I used to share an office with Frédéric de Vignemont, who was a philosopher working with Patrick Haggard, and she got me a little bit into the philosophical literature of embodied aesthetics. And if you reflect a little bit about it, and Cynthia was talking about it this morning, these philosophical theories, they provide a very important role of the body in shaping the mind and the external world in general. And you know already, this paper has been cited already, Friedberg and Galese, where basically they suggest that when we observe a piece of art, for example, a painting like this one, we embody that artwork, and we are internally simulating the action that required to produce that artwork. So in this case, if you see this, you will be internally simulating the movements that the artist required to produce that work. So we thought a little bit about this, and we thought that the body was taken maybe a bit too lightly in this context. And if we think about the body in the brain, the body is represented in the brain in many different ways. Two of the ways it's represented is in a sensory and in a motor cortex. And what is interesting of this representation is that it's organized in a somatotopic manner. So we have a very localized area for our hand, foot, and different body parts in the sensory and in the motor strip. So we wanted to actually be a bit more precise and understand when we say that we embody other person's artwork or stimuli, are we actually having a general embodiment response, or are we having a specific embodiment with the body part that has been required to do that, for example? So we thought a little bit of how to test this hypothesis, this somatotopic embodiment. And at that time, I moved to City University, and I started working with Tina Foster, who has been working a lot on tactile attention. So she was using somatosensory evoked potentials to study tactile attention at that time. And we thought that with this technique, we could actually see the role of the somatosensory cortex during a visual task. And this is basically how we did that. So we had these questions. we wanted to ask if embodiment will be general or specific, so general for aesthetic task or specific for every time we see bodies, and if it is organized in a somatotopic manner. And so I have a couple of slides now describing the design that is one of the designs I'm more happy, more proud of. I haven't published this paper yet, but let's see what you think. I will be happy listening to your feedback. Basically, the idea behind it is that if I apply a tactile stimulation, a small tap in the tip of your fingers, I will stimulate your hand area in the somatosensory cortex, and if I apply a small tactile in the toe, I will evoke a somatosensory evoke potential in the toe area of your sensory cortex. So we had a visual discrimination task where people had static pictures, and they have to decide which one they prefer. So they were very similar. And in a control task, they had to decide which one was brighter, so a visual control task. There were small levels of difference in luminance that they have to detect. And at the same time, while the people was doing the task, they had irrelevant tactile touches in the hands or in the feet. So these touches were irrelevant to the task, and they happened after every stimuli, and the participants kind of forgot about it. What was important is that sometimes the touches were in the hands, sometimes the touches were in the feet, and that the stimuli that they were comparing sometimes were different from each other in the upper limb or in the lower limb. And this is where the master design slides come along. So we created this idea of somatotopic embodiment, and we are looking for an index of congruency, where basically, if you have to judge two stimuli that differ in the arms, at the same time that you get a tactile stimulation that enhances your somatosensory cortex response in the hands, I'm going to call this a congruent condition, while if you have to judge two stimuli that differ in the legs, and I get a tactile stimulation in my hands, I'm going to call these ones incongruent condition. And we can do the same with the toes. So if I have a difference in my arms and I get a stimulation in my toe, this will be an incongruent trial. And if I have a difference in the legs and I get my stimulation in the toes, this will be a congruent trial. So what I'm going to present now is the SCPs on the aesthetic task that show the difference between congruent trials and incongruent trials. So perceptually, they are both perceiving exactly the same, only that the tactile stimulation is congruent with the visual display or not. And this is a bit of preliminary analysis. I'm really going through them, but these are these electrodes together here, and what we can initially see is that after 80 milliseconds of the tactile stimulation in the N90 and P100, there is a difference between congruent trials and incongruent trials. And this difference appears only in the aesthetic task, and we don't find such a difference in the controlled perceptual task. So this allows us to say that we do embody when we have to do an aesthetic judgment over sensorimotor stimuli, and this embodiment is actually organized in a somatotopic manner. And because this is such an early response, it also allows us to suggest that the primary somatosensory cortex is engaged and has a particular contribution during the aesthetic evaluation of body information. And I obviously still have to do the topographic maps and a few other things, but just a preliminary data. The following question will be to say, well, does expertise or a different embodiment pattern in aesthetic appreciation, or do we actually have the same? Because this is just control participants. And what we found is that They have a slightly different pattern, experts, so the responses are generally smaller, but also in the N90, we start seeing a clear difference between congruent trials and incongruent trials. And the congruent trial is very similar to the control one, but the incongruent trials, that they are the red ones, they show much more negativity. So I'm not very sure what is the meaning of it. I think that's something we'll need to explore, but something we can say is that both experts and non-experts, they show a somatotopic embodiment, and we find difference between them. Something important is that in the fMRI study I saw before with the dynamic information, when we had aesthetic judgment and visual discrimination judgment on dancers and controls on the point light display. So in that study, we had 3 seconds videos, and we find an effect of task in the somatosensory cortex, but we don't find an effect of expertise on these areas. So I'm thinking that fMRI might not pick up this expertise effect because they both show an effect in the somatosensory cortex. It's just modulated slightly different. And fMRI might not be sensitive to this, but it's just a thought. OK, so where are we now? So we have different type of observers with different type of experiences, and we know that the familiarity and the experience modulate the intensity of the simulation response, and the liking also modulate that response. What I really would like to bring along is this particular involvement of the sensory areas involved in processing the stimuli and their role to the decision-making of the aesthetic decision-making. And this somatotopic embodiment idea, and we have extended this idea. So this is what we are starting to call the aesthetic homunculus, and we have published already some work where we use SCPs as well to investigate not only the role of somatosensory cortex in aesthetic, but the role of somatosensory cortex in processing facial expressions with emotions. So we have called that the emotional homunculus, and we recently published the paper that took me longer to publish, where we also show that somatosensory cortex doesn't only participate in taking these decisions, but hold this information, this bodily information, in short-term memory, in working memory. So yeah, this is kind of like the technique that I would like to throw to you and see if you are interested in studying embodiment, like a way we could do that. And how? I would say about 10 minutes. Oh yeah, 5. Yeah. Okay. So I started at 5:30. I'm doing very well on time. I was going to say I'm halfway through. No. Okay. So then I have time to tell you how. Other things. So how these expertise effects make any difference, not only at the neuronal level, but at a more behavioral level or subjective level. Or I think it's important also to look at different responses, not only neural responses, physiological responses or subjective responses. So here, or attempt to do this. And oh yeah, so I put this slide here because I thought it's not all about dance. You could actually investigate the same questions with any motor expert. And there are many different levels of expertise. So I've been talking about experts that they have motor expertise, and they also have a lot of visual expertise, obviously, because they work together. But you can look at expertise and decompose the different levels of expertise. So if we think about another motor skill, for example, sport, some of us might be couch potatoes, so we have a lot of visual expertise on watching something, but maybe not doing it very well. If you are a coach of this particular sport, you might be actually very good. You might have been a football player before, and now you don't play so much, but you have that experience already in your body. Or you might not play, but you have had a high level of visual experience. So here I have a little test for you. So I don't know if you see it from the back, but I'm going to play a video, and then I have a few questions. It's a test, so you have to really pay attention. So let's see what you can see here. So it's a bit far away. I don't know if you saw everything, but it doesn't really matter. That's the point, that you don't have a very clear picture, but even without having a very clear resolution picture, you can make sense of it very much. So I wonder how many people realize who scored that goal. I mean, if anybody can. So there are a few males. Any female? Good. Anybody realize what leg was used to score this goal? Was the leg in the floor or in the air? Everybody realize about this? The leg was in the air? How was that the performance? Did you like it? Final question. I cannot read out loud. Who said yes to the final question? Thank you. So the point I wanted to make here is that different levels of expertise allow you to have a stronger visual sensitivity. And we particularly wanted to test that with dance. So as I said before, we had a lot of videos with ballet dancers doing different movements. And what we had is a library of movements performed by many different dancers. So if you are a very good dancer and you dance in a company and they ask you to do a padded shot, you and your friend and your other friend, they do it in a very similar way, but there will always be a small difference between them. So we asked people to spot this difference. So we had a visual discrimination task on this point-light display of dancers doing different movements, and we asked them to say that was the same or different, and we had the pictures upright and inverted. And basically, what we found is that dancers, so we have here female dancers and male dancers, all the videos were from female dancers. They are very good at doing the task when the image is presented upright, in the orientation they are familiar with, but they are not very good when the picture is presented, sorry, it's not a picture, when the video is presented upside down, inverted. So when you disrupt the configuration, you don't perceive the stimuli as you know it, you are not that good. And control participants, they were actually very good at doing very bad at doing the task, but they were equally bad for the upright or inverted pictures. So what we wanted to conclude from this study is that having motor expertise or visual and motor expertise influences early visual discrimination. So it allows you to see more. And where I'm coming is like, okay, if it allows me to see more, if experts can see more when they are seeing familiar stimuli, does this help them to understand better the story behind the action or the story behind the dance, just because they are receiving more information that I'm not getting? And with art stimuli, sometimes with some other type of art, it's very easy to understand the emotion that is represented. You all will agree that this is towards the sad spectrum rather than happy, and more or less it's the same. And both experts and non-experts are able to classify the emotion in this image. But when we move to dance, and here I'll go back to the question that people was telling me before, it's like, can you try and use more naturalistic stimuli? So finally, after many years, Julia Christensen came to work with us after creating a lovely dance library with Marcos. So she came to work with us, and she brought her library, and I'm going to put the pictures again, where she had classified dance stimuli according to different emotions, valence, arousal levels, and all the parameters that you can imagine. So we had those stimuli, and we asked participants to see them and to rate in this analogical scale the emotion that they understand in the picture. And they were doing that. The videos are along 6 seconds. And while they were doing that, we were collecting the galvanic skin response from them, because we were interested not only in seeing if they can classify the stimuli, but also if that classification, if seeing something positive or negative, change your skin conductance. So physiology can also be influenced. And we had some control stimuli, and we thought for a while which control stimuli we should use. So this is a normal stimuli, and then we thought for a while on using inverted stimuli, but that looked a bit weird. So we end up choosing this control stimuli. I don't know if you noticed the difference, but it's basically the video played backwards. So people like me, I find it really difficult to distinguish between the real video and the one played backwards, but dancers can distinguish them very well. And this is what happens. So these are the behavioral data. So controls can more or less, this is significant also, not amazingly, differentiate between happy videos and sad videos. Dancers can do it much better, and they are sensitive to the control manipulation forward and backwards in the happy stimuli. The controls, they are not particularly bothered about it. They are not sensitive. I don't think they even notice. And importantly, the galvanic response. So we classify the stimuli according to each individual preference, so what people have chosen as happy and sad, and reclassify the stimuli again. So it's not anymore the classification that Julia had in her paper, but the individual preference. So we reclassify the stimuli according to the individual emotional categorization that they have done, and we found still no difference between the controls when they were rating happy stimuli and sad stimuli, and no difference also when the video was forward or backwards. But for the dancers, while there are no difference in the backward condition, we found a significant difference in the forward condition between positive videos, happy and sad videos, suggesting that that expertise is not only reflected at the behavioral level, and they are more able to discriminate, but also they are feeling that discrimination at a physiological level. So we have different layers now of expertise, the neural level, the behavioral, and also the physiological one. And I wanted to put this last study because I feel I'm one of these guys, I'm the non-expert, but I do appreciate emotions, and I understand emotions, and I might not be expert, but I'm able to discriminate between positive and happy. So we had this other study that is not about aesthetics, it's about emotion, but it looked at the role of your own body when seeing emotions. And we did, you might remember these very classical studies of Stark, where if you hold a pen in your mouth, like posing a smile, like this, you are a bit quicker in ticking all the happy faces from in a search like that than if you hold in your mouth a pen with your teeth. So like, contracting your muscles but not posing a smile. So we wanted to see if that had an effect at the neurological level. And we put participants in the Faraday cage with an EEG cup while they were holding the pen in this happy smile position and in a different control positions. And they were rating the emotion, the level, the intensity of the emotions of happy faces and neutral faces. And what we found is that in the classical N70, and so this is an enlargement of this area here. So the two areas in the green and the red one, that they are more negative, are basically when you see other people happy faces. So there is more negativity in the N70 when you see happy faces. This is well known. And there is less negativity, the black one, when you see neutral faces. The important line here is the blue one that is when you are seeing neutral faces, but you have a pen in your mouth holding a smile. So when you do that, your neurological response in the visual cortex, move a bit more negative. So rather than staying with the neutral faces, you perceive neutral faces a bit more happy. And I'm not talking behaviorally. I'm talking about how that muscle response influence this neural wave. So there is hope. So the body also in the controls have a role. So we can. There is hope for the non-experts like us. And I put this study because I thought it would be quite interesting to see if people walk in a museum with a pen in their mouth or a happy smile. This is about recognizing emotion, but are we also able to enhance an aesthetic experience with this very simple, like muscle feedback from your mouth? And this is basically my conclusion slide for my minute left. So this is what I said now. I wanted to show a little bit of this work by Julia Christensen that she was going to come here to present it, but she could not come. And I guess the next question is, what is next? And I don't know, I guess there are many possibilities to go from here. I'll be happy to see what you think. Obviously, I think now it's time to look a little bit more at this multisensory integration of the action, including other people, music, looking at the context. I know Emily will probably talk about how can we entrain people so they behave more like experts. And something that I have been doing with Julia in the last year, it's looking at why expertise stays so this enhanced affective experience. And one of the topics that has become quite popular, and I was quite pleased to listen this morning to Cynthia highlighting the role of the insula in interoception process of mechanism, because we've been recently looking if experts have this enhanced experience because they have more body awareness maybe, or higher interoception accuracy, or something along those lines, and this is the work that we are doing these days. So I leave it here. I wanted to really thank again Ed for, since a day and a half we have been spending a lot of time together. I have a lot of interesting discussions. I had many more pictures I haven't dared to put here. Many of you are not here. You haven't spent enough time chatting with me, so it would be really nice to meet you all. But finally, to thank also all the people I collaborated during this last year. So, all the dance community, that is lovely to have see you again in every symposium. And Cosimo, Jesse, Julia, who did the last part of work, Alejandra, who did the motion studies, Bettina Forster, who introduced me to the wonderful world of the somatosensory cortex, and my previous collaborators during my PhD, and my current PhD students. So, thank you all. Thank you.